Hello to all astronomy enthusiasts. Today we're going to talk about mankind's incredible journey to find new worlds, exoplanets, planets outside the solar system. Scientists have discovered thousands of exoplanets in recent decades, and each one reveals something new about our universe. But how do they find them? What methods do they use to see planets tens or even hundreds of light years away? We'll talk about the most effective and surprising methods astronomers use to find exoplanets. What are exoplanets, and why are they so important? Exoplanets are planets that orbit stars outside of our solar system. These celestial bodies are of particular interest to scientists because they can answer the question, are we alone in the universe? By studying exoplanets, we can understand whether other parts of space have conditions for life similar to those on Earth. Moreover, the search for exoplanets expands our understanding of the formation of planetary systems. The main challenges in the search for exoplanets. One of the main problems is that exoplanets are extremely difficult to see directly because they reflect very little light from their stars and are virtually invisible against their bright light. It's like trying to see a firefly next to a powerful spotlight at a great distance. Therefore, to search for exoplanets, scientists are developing methods that allow you to notice not the planets themselves, but their influence on the star or the light passing through their atmosphere. The transit method. The method of transits is the most common and effective way to detect exoplanets. When a planet passes between its star and Earth, it partially blocks the star's light, and its brightness drops slightly. These small changes in brightness observed by telescopes allow scientists to determine not only the presence of the planet, but also its size, orbital period, and even the density of its atmosphere. How it works. A space telescope observes a star and detects tiny changes in its brightness. If periodic dips in brightness are repeated, this can indicate the presence of an exoplanet passing in front of the star. Examples of the method's use. The Kepler Space Telescope has discovered thousands of exoplanets using the transiting method. TESS Transiting Exoplanet Survey Satellite continues its work by observing bright stars in search of transits. Radial velocity method, Doppler method. The radial velocity method is based on the Doppler effect. When an exoplanet orbits its star, it slightly nudges the star, causing it to shift slightly in space. This oscillating motion causes small changes in the wavelength of the star's light. As the star moves toward us, the light shifts toward the blue spectrum, and as it moves away, it shifts toward the red spectrum. How it works. Telescopes analyze a star's spectrum for changes in wavelengths. If periodic changes occur, it may indicate the influence of a planet orbiting the star. Interesting facts. This method was one of the first ways to search for exoplanets and was a breakthrough in astronomy. One of the most famous examples is the discovery of the first exoplanet around a Sun-like star, 51 Pegasus b in 1995. Microlensing method. The gravitational microlensing method is based on Einstein's theory that massive objects can bend space and time around them, causing light to focus. If a planet passes in front of a distant star, its gravity can temporarily amplify the light from the star, creating a lensing effect. How it works. Telescopes detect sudden flashes of a star's brightness when a massive object passes in front of it. This method is particularly useful for finding planets at significant distances from Earth and can detect planets with orbital periods of tens of years. Examples of success. The OGLE Optical Gravitational Lensing Experiment program uses the microlensing method to search for exoplanets, especially those far outside our galaxy. Direct imaging. The direct imaging method is one of the most difficult but unique ways to detect exoplanets. Here, scientists try to see an exoplanet by blocking the light of a star with special coronagraphs to pick out the faint light from the planet. How it works. Special equipment reduces the brightness of the star's light, allowing nearby objects to be seen. Infrared telescopes, such as the Gemini Planet Imager, can detect the light emitted by the planet and observe it in high resolution. Features of the method. Direct imaging is used for planets at great distances from their stars, such as young gas giants. The James Webb Telescope can also make important direct imaging discoveries with its powerful infrared instruments. Atmospheric spectroscopy. Once exoplanets are discovered, scientists analyze the composition of their atmospheres to determine if there are traces there that indicate the possibility of life. Spectroscopy is a technique that allows light traveling through a planet's atmosphere to be split into different wavelengths, determining which elements and molecules are present in the atmosphere. How it works. When a planet passes in front of its star, some of its light passes through the planet's atmosphere. Scientists analyze which wavelengths are absorbed by the atmosphere, allowing them to determine its composition. Why it matters. The presence of molecules, such as oxygen, methane, or carbon dioxide, can indicate biological activity or potential conditions for life. The James Webb Space Telescope will play a key role in this line of research. Space missions to search for exoplanets. Space missions are an important part of the search for exoplanets. Over the years, NASA, ESA, and other agencies have launched telescopes specifically designed to discover new worlds. Let's discuss some of them. Kepler, launched in 2009 and has discovered thousands of exoplanets, changing our understanding of the universe. TESS, successor to Kepler, aims to find planets in bright and close stars. James Webb Space Telescope, with its unique infrared capabilities, explores the atmospheres of exoplanets to find potentially habitable worlds. Future missions and search prospects. In the coming years, astronomers plan to make even more progress in the search for exoplanets with new space missions and ground-based telescopes. PLATO ESA, focused on finding Earth-like planets in habitable zones. LUVOIR and HABEX NASA, future telescopes that will allow the direct study of exoplanets and the detailed study of their atmospheres. The search for exoplanets is one of the most exciting areas of modern astronomy. It not only expands our knowledge of the universe, but also brings us closer to answering the question of whether there are other worlds like ours. With each new discovery, we get closer to unraveling the mystery of life in the universe. If you enjoyed this video, don't forget to subscribe so you don't miss new exciting stories about the universe and its mysteries.